Welcome back to lesson 9 of the Java tutorial series, and today we are going to talk about abstract interfaces and inheritance. So, this is a continuation of the object-oriented paradigm of Java, which is pretty much most of Java. It's what Java is known for. As I said, if you haven't watched my previous videos, please go watch them. It is very important for you to watch. Starting from lesson 7, if you don't have much time, just start from lesson 7, watch lesson 8, and now pick up at lesson 9 and we'll get started. So we're really going into the details of, object-oriented programming and seeing how we can possibly use its features to the max. So one thing we can do is to inherit methods and abstract everything. So I'm going to show you what that means. So let's go head on over to Eclipse here. So we have this, thing that I set up previously that I just created some files. They're called employee. Whoops, let's remove that. We'll get to there. You'll know what extends means in a second. I was just messing around before I started. But we have employee, salary, which is an abstract class. We're going to get into that today. And yeah, so basically, we're starting from scratch again. We're going to create a few private fields because remember from last video, private fields are very important. So let's do private integer phone number, private string name, actually all caps, this is convention, and private string address. So we have some basic properties of your employee. You got their phone number, name, and address. Now let's do our constructor here, which is going to be public employee int number, string name, and string address. So our constructor is defined, and we just follow through with this dot address equals address, this dot name equals name, and this dot phone number equals number. So this is just creating the constructor here, and in fact we can add some sanity checks along the way just to make sure everything is working fine. So we can just do a quick little print statement just to let them know, we can do created employee, so employee, with property. Actually, let's not go that far yet. So we can create employee. So that is our constructor. And again, we're going to add print statements along the way just to help us know what everything's going on and how, how the compiler deals with everything. So we can actually do another feature here. So let me just copy and paste it. I have this preset ready, which is this here. We can do mail check. So mail check, this will mail whoever it is to the other person, so their address. So mailing check to name, and let's do a comma here, so comma address. Actually, yeah, let's do a colon like that. This is your just a normal method for you, nothing that bad. And we can also do a public let's do another method here, public call int, actually public void call, and then we can do system.out.println and calling, just gonna add that, and calling this dot phone number. So, you can see, actually, we can do this, but let's see. Okay, we're going to get to that later. But you can see we have a few, methods at our disposal. We have some private, private fields because it is good to keep fields private. And we can also, do some other things, but when let's see, when we actually create our employee here, so let's go back to our main class, our public static void. So we're gonna follow through employee. Let's do employee John equals new employee. And well, remember, this is the constructor, so if we take a look at here, it wants number, name, address. So the number will be 1234. Name will be John Doe. And address will be 1234 Main Street. Like that. So now we have instantiated or constructed this new employee called John. We added their credentials in, and now we can actually, for example, we do John.mail check. Remember, that's one of our methods here is mail check. So it should print mailing a check to John, 1234 blah 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 Main Street, right? So when we run it, you can see that it works. Create employee, of course, it creates employee, mailing a check to John Doe, 1234 Main Street. So, that's pretty much review of last time. And now we are going to get on to the abstract class. So the abstract class will be let's change it to employees. So for example, this employee class currently is a normal class, right? Everything's normal, but we're gonna change it. So in fact, we're going to change salary back to a normal class because just had a sudden realization that it doesn't quite make sense to make the salary a abstract class, but it will make sense for the employee to be an abstract class, because if we're talking about inheritance here, you'll see that salary is basically going to inherit employee, not the other way around. It just doesn't work like that. So let's change this to abstract class. And yep, everything should work fine. Nothing changes. Everything is good. Same thing. And when we run it, let's just run it. You can see it already says there's errors. Let's go back to this X here. You can see we cannot create a constructor in the abstract class. Now, that is very, very important because abstract classes are not meant to be, no constructors in there. But what we can do is we can relocate this. Where are we? All right, so let's copy and paste all of this. Just remove the constructor and paste it into the salary class. Of course, naturally we have to name this salary. And right now it's going to give me a bunch of errors because it doesn't know, where all the private fields are and all of that good stuff. So we're just gonna hold that for a second. And now we can see that we need to create some things for us. Most notably, we gotta create some methods in the abstract class so that we can get all of these variables. First of all, we can get public void get number, And let's do return. Actually, we should do integer, should we? Yeah. Return this dot number. Like so. Public int get address. Return. Oh, I am horrible on my type game today. Public string. Yes, public string get address. We do return this dot address. And finally, public string get name will return type string name, and that will be return this dot name. So just like that, we have a few methods to access our private integers, because remember, we can't access them from salary. So we'll leave that here for now. But right now, we gotta go back to our main class. You can see we gotta change this to salary. And right now, it's still throwing an error because we haven't done one thing yet. And you can see at the beginning, I kind of gave you a sneak peek here, which is public salary. We got extend our employee. So this is very important because whatever you're extending here, extends, there we go. Whatever you're extending here, this is your parent. So basically, what you want is that employee owns salary. Salary is a subsidiary of employee, not the other way around. So employee is the base class. What this is doing is basically saying salary is an add-on, not the other way around. It's not employee extend salary. That's why. Because that would make sense. You have the salary class and you extend employee. Like, what? That doesn't make any sense. But what it does make sense is you have this employee class and you can extend salary because, a salary is an attribute of an employee, right? So that is basically what this extend keyword does, is that it assigns whatever is after the extends keyword to the parent of the current class. For example, salary. So right now, you just saw that, that is currently a thing. So extend keyword creates that abstractness. Is that even a word? Abstraction. Yes, abstraction out of the employee class. So that is basically it. But you can see right now we still have errors. Why is that? Well, I did this on purpose because you can see that address isn't defined here, right? And we want address to be defined. Well, I'm glad you asked, because let us copy and paste the constructor back. It turns out you can have a constructor, but not in the way you think everything works. So right now this is totally valid. And now just remember that employee is parent of salary. So technically employee owns salary. So let's create a new parameter called double salary. So again, this is the salaries constructor. Let's see. Alright. So, salaries constructor, we have abstract type employee constructor. And now we can access all of these variables by using one keyword. So that keyword, of course, is the superscript keyword. So to do that, we will type super, because remember, sub prefix means below, and super prefix means above. So again, employee is parent of salary. If you look at the hierarchy, basically salary inherits employee. So that's where the inheritance of all of this comes from. But basically that's what inheritance is. Basically inheritance as defined, but super is referring to the parent of the salary class. which essentially is basically, the constructor for the employee class. So we feed that in. We feed all of those in to the superclass. And you can notice this is the equivalent of this constructor class. So we're feeding this in. And just to prove that this is the equivalent, once we run this, you can see that it says created employee. But our salary class also has to be unique, because what this does is it's accessing this constructor class. So that is what is doing. That is what that's doing. So now we can actually define some more classes. Let's just leave that here. And we can, for example, let's do public void set salary, and let's do, actually before we do that, I just want to show you a handy dandy thing that we can do is let us delete all of this for now, because that is basically review from last time about the private and public things. But we can actually add a abstract method. So to do that, we are going to go back to the abstract class. We're going to do public abstract void set salary. I could have just done it in that class, but I decided that I want to do it in this class because the abstract methods are important. So do double salary, and you can see, well, this is weird. You don't have any body here. So there's no body of the abstract method, because the method won't be defined here. It's defined in the child class, which is the salary. So to do that, you can see it's already Eclipse. Again, Eclipse is impatient. It's just saying, you have this abstract method, man. You gotta define it. So that's what we're gonna do. So calm down, Eclipse. We're defining it. So to define it, we want to copy and paste everything you see here, minus the abstract. So we want to just write that public. What was it? Void set salary. Double salary. You can see there's no error because automatically it has this little blue arrow. I'm not sure you can see, but it says implement employee.java. So right now, when we click on that, it'll bring us back here to this set salary class. So that is pretty neat feature of Eclipse. I don't know what IDE you're using, but Eclipse at least does that for this, inheritance, So let us actually define some things. So we can do salary. If salary is greater than 0, let's see, we can do 0.0 because it's a double. Salary greater than 0. And one more quick syntactic sugar here. If you don't know what that means, syntactic sugar is basically syntax, but we want to make it look neater. So in fact, Java has this feature where you don't have to put braces around your if statement. You're like, what? Yes, it's true, but it only works for one line. So in this case, we're just going to do return. Actually, let us add a private field here. So private double salary return. Okay, so we can do return this dot salary. But if we do something else, for example, let's do return. Let's not do return. Let's do int a equals 1 plus 1. This wouldn't work because you can see that it only works for one line of code. So this doesn't work. This is the equivalent of this. So basically, if you don't want to put braces over the if statement, just note that make sure that whatever comes next is only one line. Because if you have multiple lines, you just gotta put that brace in here, and then you can just copy and paste, and now everything will work. But right now, let's not go worry too deep in that. Right now, again, we're setting the salary, so we're just doing this dot salary equals salary. So just like that, we're setting the salary, and now we have the salary class. So we can create another method in here called let's do public abstract void. Actually, let's do double get salary. Right, so again, another abstract method. We know the drill. Just copy and paste it in public void, actually public double get salary. And then just like that, you can see that return value. So you return this dot salary. So now you can see another arrow. We successfully inherited this abstract method, and now we're putting it to work. So that is pretty much it for the abstract side of things. Now we are going to head on over to our main class, because you can see our main class is still broken here. So to do that, we are going to add another thing. So let's get their salary. One more thing is we are going to go back to salary, and we're gonna call set salary. So we're gonna do set salary because we want it just to, all in one package. We have the salary. We're just gonna use it here. So salary, and now it's basically gonna do this for us. In fact, we don't even need to make it public. We can do it private, but we can't do that because we're inheriting from employee. So let's keep it public, or we could just keep it void. But again, we have abstract methods. But if we can remove this, so let's remove all this. So again, no more inheriting. So we can rename this to private. That way it doesn't expose all of this random unnecessary methods, because these actually, yeah, we should change this to public. But right now we have a private set salary because again, the only place that this is accessing is from here, and that's in the class. We don't really need to call the set salary because we're doing it in the constructor. And I'll just show, for example, we're gonna give John a salary of $50.59. Very odd, but hey, it works. So that will get feed into salary. You can see it constructs the employee. It sets the salary to 50.59, but it doesn't require the main function to expose this private set salary thing. So that's basically what we're doing here. And then we can do system.out.println John.getSalary and right, we have to change this to salary, and now it should work. You might have noticed this was employee the whole time. Why didn't it throw an error? We're calling this a salary function, but why didn't it throw an error until we got here? Because we didn't have that. Well, my friend, that is a great question, because for the next episode, that's what we're going to talk about. That has to do something with polymorphism, and that is very important, but topic for next time, because we are already a little bit over time. We still have to get to interfaces. So yeah, hang in there. The next lesson we'll talk about how, if we change this to employee, you can see it still works. There's no error. Obviously there's an error here because employee doesn't have this method, but there's no error in defining it. So what's going on here? So we'll get to that next time. But once we do this, we will see that it gives some things. We can create employee, and salary will be 50.59. So, I mean, that's pretty much it. And then, of course, we have this call function. But, okay, so this call function here, we're going to put it to use because we're going to create a new thing called an interface. So, interface achieves total abstraction. Basically, everything is abstract classes. I'll show you what it means. So, let's create a new interface. And convention for interface is right before what your class name is, you wanna type it I. So I employee. So we're creating an employee interface. We just want to name it I employee. So let's do finish. We have this lovely interface called I employee because we're letting people know that this is an interface, and we can achieve total abstraction by doing the following. So we'll put these two methods to use because right now they're not really in use. So let us do this by doing public void mail check public void call. So you can see total abstraction. We don't need the abstract thing here. We don't need this because it's unnecessary. We already are achieving abstraction. So obviously Java wouldn't really care if you put this here, but why put it there when you can just do this? Save time and energy, and basically this is the equivalent of a interface. Again, this is redundant. Interface already abstract, so it's kind of like saying, I'm burning on fire. Burning what you're already burning. Yeah, you're on fire. So that's basically it for interface. Nothing else, just the declaration. If you have parameters, you can add stuff in here like int double. Actually, no, why did I name it double? All right, we can do int like int num, but right now we don't need that because we are going to go back here. You can see we have these exact same methods, but we want to implement this interface. Now the key word, I just said it, is implement. So we can do two things here. We can either implement an employee or salary. Let's do employee. Implement. Let me see. Implements I employee. There we go. Again, add that S because or else I spelled it wrong. And now we can see that it's taking whatever in here, and now we got add this annotation. So we just do the @ symbol override. So we're telling Java that we're overriding it, and yeah, this is actually optional because we don't really have anything in the interface. So I would recommend you not to add override because that is just redundant and useless. So you can see it already it extends this functionality. Now you might ask, well, interfaces are pretty boring if you ask me, because like what even are they for? They well, here's the deal. When you're working with APIs, it's nice to have everything in a nice orderly interface. And that's exactly what it is. It's an interface. Think about user interfaces. They're meant for ease of access. Same thing with this. They're meant for ease of access for developers. And that's the reason why when you're writing source code, think of this as like a header file. If you ever script in C++ or C, you will know that a header file doesn't really contain any doesn't really contain any content. It just contains declarations. So that's why we use interfaces. And I'll show you a primary example of overriding, because that overriding annotation is very important. So we're gonna override this mail check function in salary. All we have to do is we're gonna copy that over, public void mail check, and what was the parameters? Mail check, oh right, void. Alright, no parameters. and it's gonna do system.out. Let's do that. Copy that over. But we have to alter something. Let us alter this thing. So again, we don't have this dot name. What is this dot name? It's nothing, right? So we have to do super, right? Hello, why is this blue? Should be orange. Super dot get class. Actually, I probably shouldn't use this method. Let's do super. Let's see if we can get the name from here. Oh right, we're having a issue with the private field. So let's just write the quick function again. Public void string get name. Totally forgot about that. So we need to return this dot get name. No, we are not doing recursion. Return this dot get name, and then once we go back to our, what was it? Salary. Yes, we do, instead of doing super, we do super dot get name. Again, super is just referring to employee, so that's what. Yeah, there we go. Okay, and then we can do super. We can do salary. You can see we changed it because originally it says address, but now when we do mail check, we're instead of telling them the address, we're telling them the salary. So do that. On top of this, we will now add the override function. So we will now add override, and now everything should work. So once we run mail check, we can do john.mailcheck, and it will say well, it'll say mail to John and then 50.59 something. So yeah, you can see mailing a check to John Doe, $50.59, because we overridden the other thing, majiggy. Where was it? Yes, back here we overrided this mail check, and yeah, so that is pretty much it for abstract classes and interfaces. So one more thing about interfaces is that you can actually make them a declarator. I'll show you what I mean. So basically, we can change this. Yeah, where are we? We can change this to employee. So employee. You can see, obviously, we don't have any get salary method, but just to let you notice that interfaces can also be a declarator type, just like so. Of course, since salary, let's actually do this just so that we can see it works. We can do public void get salary, and then when we go back here, let's change this to public. Oh right, double. Whoops. Public double. Public double. So interfaces work exactly like classes, but they pretty much have nothing in them. So we change the public double, and then we wanna do. Okay, so you can see we don't even have to implement it, because we can do implement employee, right? But that's redundant because we extended the employee class, and if we go to the employee class implements interface. So you can see it automatically adds that little arrow for us, because again, everything in the employee class gets copied over here, and you can see that we don't need to write implement employee, but just so that you can see what's going on behind the scenes, it is actually implementing employee, because employee, the interface, sorry. So that is basically it. So when we run this, you can see get salary works because John isn't a John isn't a John isn't a salary employee object anymore. He's an employee interface, which of course basically John has all these methods at his disposal, but John doesn't have this call method because the call method is not within the interface. So if we do John.call, I think naturally it will throw an error. You can see you got. Wait a minute. I guess you can. I guess you can get what I guess you can't get what it implements. I didn't know that because I thought that when if call isn't defined here, it is defined here. Oh my god, I am so dumb. All right, let's find the thing that isn't defined. So just to show you, because I thought I was tripping because John.getName. There we go. There we go. You can see that getName does not have, it doesn't exist. Well, it clearly exists in employee, but it doesn't exist in the interface. That's why. Yeah, for a second I was like, wait a minute, does it really get the method from the implementing class? But nope, my memory is correct. It's just that when I do John.call, it's actually defined here. So, quick recap, we basically learned about abstract classes and interfaces, and just like that last thing over there, we can actually take a look. You can see John.call, once we run it, it works because we have call method, but John.getName doesn't work because the interface does not allow that. Employee John can create a new salary interface because the salary implements the interface. It also extends the employee, which is the parent class of the salary, also an abstract one, that basically uses the super keyword for the constructor of the parent class. So next time we are going to talk about polymorphism, because remember what we did here, we're slowly foreshadowing polymorphism, but right now you can see it is possible for us to have a different decorator type than a constructor method. Obviously, salary and employee are different. Next time, we are going to see how we can make this possible. So, we'll see that. And yeah, that will be it for today's video. If you enjoyed this video, please leave a like and subscribe. And stay tuned for the next one. And stay safe out there. I'll see you next time. Peace out.